either in a package or already loaded in R. Now, how can we create our own function? That's all we're going to do, and that is user-defined functions. So the structure of the function is like this. The structure of a function in R is like this. We have the name, and then we have this assignment statement. Then there will be function, and then we pass in the arguments. Okay, then we open a bracket, we close the curly bracket. So over here will be the body of the function or body or statement. And then the results, we will return results. So that's how the structure is. So that's something. So now how do we open it? Create our own function. So let's look at okay, so when we go to hospital, sometimes they bring a machine called body mass index machine, right? And so if we get your, so let's see here. So your weight, maybe this is in pounds, kilograms. So let's say you are 120. And then height in kilograms, in meters, right? Let's say 1.75. Then we calculate. It's 39.02. Then we check. Then they now refer you to the nutritionist. Is that okay? How is this done? Well, BMI is what? Weight over what? Height squared, right? So we can write our own function to do this and even do the classification. And actually you can deploy it as a Shiny R or in HTML, just like this. And then people can just put in their weight and height, and then they compute the BMI for them. So this we are going to write our own function to perform the same task. Is that okay? All right. So let's go back to R. So all we need is this formula, right? Height, weight over what? Weight in kilograms over height squared. So let's get back. So what is the name of our function? We may name it what? BMI. So BMI fun. That's the name I chose for it. You may choose a different name. Okay. Remember we need what? A function from there, right? Function. Then what will be the argument we have to pass to this function? What data do you need? Pardon me. Weight and height. So weight, height. Okay. So that's all. And then what do? We open the curly bracket. I open it, I press enter so that I work within it. Don't delete anything. Work within the bracket. So how do I compute the BMI? The BMI value will be equal to what? Weight divided by height squared. There are several ways you can write height squared. One way is height raised to the power 2. Another way will be what? Height times height. Another way will be height times 2, which means height raised to the power 2. So it depends on you. Okay. So this is the statement. Then I can return BMI. So this is a simple function to compute BMI. So let's see. Now, when I finish this, I can also put this in quotation marks. If I do so, what it does is that it makes it available to my global environment, which means I can call it within another function and so forth. Okay, so sometimes, usually when I write a function, I put the name in quotation marks. Okay, so you run this. Now, look over here. If you check our environment, there is no function there, right? So once we do this, it's going to split our destiny into data and functions. And you see, because the function is also an object. So you see we have what? BMI function, which is our own function. So when we define our function, we will see that. Okay, now let's see. How do I use this function? Well, I need to call the name just like we've been doing for the other functions. What was the weight that we checked from the example we did online? It was 120, right? What was the height? 1.75. So we compute this. What was the answer? Online, 39. It was what? 39.2. What do we have over here? 39, which is 39.2 to 1 decimal place. So what we are doing is correct, right? Okay. But we need to be able to do this function in such a way that it should bring us the height, the weight, and then the BMI. Okay. And of course, you even have the classification, which I will leave to you as an assignment. Okay, so now let's see. How do I obtain this? So I want to be able to even enter more people, and I want to get height. So I want to report height, then weight, then BMI. So maybe number 1, the height is 1.75, 120, and we have 39.2. Remember, this is 1 decimal place, right? Okay, our own is how many? 5. So we have to round it to 1 decimal place, or at most 2 decimal places. How do I do this? What kind of structure is this? And now, how can I get this structure? With data frame. So it means that what we return should be what? A data frame. Not just one. I mean, nobody will know. If they run it and they won't know what it is about. So it means that we need to go back and what? Refine our function. So I'll copy it, then we will now make sure that it has it. So when I come here, instead of BMI, I'm going to, let's say, call it tab, and then I call a data frame. So the first one will be what? Height. Or I did weight. Height, yeah. So height, weight, or let's say if I want it to be like this, I'll say height is equal to height, weight is equal to weight. Remember that what I use in the small letters, right? What I was passed, the arguments are small, but I wanted to name it like I did over here, they are all capital. But if I just put height and weight, it will also appear like that. And then lastly, BMI is equal to the small BMI. Okay. So it means that the return, I'm only going to return what? Tab and not BMI. Is that okay? Other than that, I did not round it as well. So I need to round days to how many decimal places? 2. Like that. Okay, so now let's see how this works out. Okay. So I call BMI again, I run, there it is. So this looks more appealing, right, than the other one. Is everybody okay with this? Yeah. So what we are left with is the classification. I'll leave that to you as an assignment. But if you, let me see, let me get the function video because I remember I've done this over the years in class. So in this assignment, you have to look at what is conditional statement. So here we need to use if. If the BMI is less than 18.5, we say you are underweight. Else, if you are less than 20, is it 29 or 25, we say you are normal weight if you come over here. So 24.9. So less than this, underweight. Between this, healthy weight. 25, overweight. Here, then the answer. And so forth. But there are several categories. If you go, they subcategorize them. So please make sure you are able to do this. So when you finish this, you can sample. So you see, I can ask, let's say, 8 people over here your weight and height. That's if you know, then you tell me and then we enter. Okay. But that means I have to ask questions. I can do what we call simulation, which is that I can actually just generate a sample of weight and height. How do I do that? Well, weight, I may say, well, if I look at this class, you may be maybe between the maybe 50 kg to, let's say, 110. Okay. So it means that I can sample weights from numbers between 50 to 110. How do I do that? I use sample. So sample has X, which is what you want to sample. The size is how many you want to take, and then replace. In this case, 2 people can have the same weight. Is that okay? Yeah. So it means that if I have to say replace is true, right? So I take sample. X is equal to 50 to 110. Size is equal to 8, and then replace is equal to true. So this will give me a sample of what? 8 weights. All of us are going to get different different values because we are sampling is random sample. So remember that if I want to do this and display at the same time, I put all of it in parentheses. So the first person I weighed 90, 98, 76, 107, 79, 105, 79. And you see we are 79 because I said in practice you can get 2 people or 3 people having the same weight. Okay, so that's how we mimic real life data, and that is sampling. Okay. Now I can do the same for what? For height. Okay, but in the case of height, I cannot be moving in steps of 1 because it is in meters. The highest I could go is maybe 2 point. Nobody is 2.0 here. Is that okay? So, or 2.3 and so forth. Okay, so what can I do? I can get a height from a uniform distribution. So from your probability distributions that you are doing, I can get it from a uniform distribution. Okay, so the uniform distribution, I specify the minimum value, the maximum value, and the number of observations I want. Right. So how many do I want to take? N is equal to what? 8. What is the minimum height over here? Maybe 1.4. Right. And then the maximum, let's choose 2.0, like this. So I run this. This is also going to give me a sample of what? Heights. So this is 5 decimal places. I want to round it to what? 2 decimal places. So what do? I put all of this in what? In round. And then I give it a 2 as the digits. And I run it. Okay, so each time I do it, I'm going to get different set of values. Okay? But if I want all of us to get the same value, we will set a seed. So let's set seed. So set seed is to help us generate. So you can put any number there. Let's say 2,000. And do the weight. We should be getting the same values. So please let's do it and let's see. So this is how we obtain what? Real samples, which is mimicking real life. And this is what we mean by simulating observations. And most times you work with this if it works before you put it into practice. Okay, so the pilots, they say they have what? A flight simulator, right? Yeah. So that's the thing. You cannot be joking with people's lives or practicing with people's lives. That's why even in medication, you start from the lab, then you get mice and other pigs before it now comes to human beings. Okay. Please, are we okay now? Are we okay? Shall we? Hey, we did not take a break and it's almost... Yes. The what? If you... Oh, you can undo it. Oh, it just works once. Yeah. It won't say every time your generation will be the same. You see now it is changing. Yeah. So it's just an immediate thing that comes after it. Oh, so it's just a number. It has to be an integer. Positive integer, but we must use the same thing to get the same result. Okay, so this is about random number generation, right? So it can be Lotto numbers. That's why when I'm not sure NLA, they want people within NLA to stake the Lotto. Because of course, I mean, if they are using machine, if I know the seed, I can win. or the jackpot. Yeah. So computers do not really give random numbers. They are called pseudo random numbers. Because if we know the source, we can be generating it. That's not what they do at the one they print on what do they call it? The Lotto forecasters. If you do statistics, you never do that. Okay. So please do this and we should all get the same 70, 80. But if I run again, that set of seed is no more. Okay, so if I want us to get the same height, we can set a seed again. We can even use the same, or let's use 1, 2, 3. Okay, then we can get the same. Not everybody will get the same. Sometimes it depends on the operating. That's what I'm saying, that you must write the same number to get the same random number generation. Yes, so let's say if you are doing an assignment and I want all of you to get the same result, I'll provide you with a seed. You know, sometimes you collaborate and random number generation, if you give me a graph based on the random, I cannot get it again. Even you, if you don't set the seed, you cannot get the same graph again. So when you are working with people, especially collaborating, when you are doing random, you set the seed so that the person can replicate it. So this is for replication. Or generate same random numbers. Please, are we okay? Can I move on? Okay, so now we can now call our function to compute the BMI for these people. Let's all use the same set of C so that we get the same result. So we call our function and then we say weight will be equal to what? Weight. And then height will be equal to what? Height. Okay. So now when we run this, you see this is nicely done. So if you were to be at the hospital, you have your graph and then you go and check the patient ID. So those who are overweight, you know them. It seems all the people are overweight. Oh no, some are underweight. 18, this one is underweight. The patient number 7, good, normal weight. Number 4, the rest are overweight. Okay. So that's it with functions. Any question? Yes. Yes, you can. If you want to input it, you can write on the board. I can write, enter your weight. Then I read it. Enter your, I can do that as well. If you want to do that, you use CAT. C80. The normal CAT we see. So CAT, I can write CAT. So here, I can write CAT and then enter weight. Maybe in what? Kilograms. Like that. Then, what I'll do is that I'll write weight is assigned scan. So this will prompt me, whatever I enter, it will read it and assign it to weight. Then I now do again, enter height. Then you enter, I scan it as height, and then it moves. So there's so much you can do with this. Okay. All right, so let's move on. Now I'm going to talk about grammar of graphics. Please, when you go home, there is what? Classification. So that's your assignment. So modify the function to now provide classification. So this one we say overweight, underweight, and so forth. Okay, so you can do it in groups. Okay, no more than 5. Okay, now grammar of graphics. Grammar of graphics. So now what is this? Remember we talked about grammar of data wranglings, right? Where we saw some verbs. Similarly, the graphics can also be done in that way. Now the philosophy here is to now put, we will have data. You see, usually you have a data set, right? And then you want to transform like what we have over here. We had a data which was on what? Price. Usually a data frame. Okay, now we want to be able to get a graph for it. What the grammar of graphics does is that it breaks this into various categories. So for example, we have some mappings which maps the price to the x-axis, and then you have one which will now count the number of observations within that group or with that price on the y-axis, which is the frequency. Then you can see some bars over here. Is that okay? And so forth. Okay. So what this grammar of graphics does is that it can segregate this, okay, and then it helps us, just like we did pipes, to be adding on to these graphs. Okay. So instead of this one histogram and you get everything, we can now begin to get the space, labels, and then we add on to it and so forth. Like that. Okay. All right. So what do we do here? So first of all, we have data. So what is the data? That's what you have been presented that you want to show, okay, to with the graphs. So usually you have what? A data frame. But remember that you can also have a vector and you want to plot it. So it's not, that's why I said usually. Okay. Then B, there is what we call aesthetics. So usually we are going to use the AES. So what are the aesthetics? That's the mapping. Mapping of the parts of the data. So what is this mapping? Remember in this one, price was mapped to the x-axis. And the number of observations that occur within that price is mapped to the y-axis. So that's the mapping of the parts. Mapping of the parts of the data to chart component. If I have a scatter plot, it will map 1 to x, 1 to what? Y. Okay, and so forth. So then, so I've sent you a cheat sheet, which is what we'll be using to learn about this ggplot2. Actually, we'll use ggplot2 to implement this. Okay, C. Then we have what we call geom, or so geom. Let me do it this way. So, but they are together. But this is how it will be implemented. So geometry. So when we are using the ggplot, it will take data, then AES and geom. But the full meaning is data, this one is statistics, and then this one is also geometry. So the geometry is the specific visualization type. So in this case, we have what? A histogram. In some cases, it will be what? A bar graph, a box plot, and so forth. So that's what the geom will be. And then D, we have stats. And that is statistical. So that's statistical transformations. So here, this gives us how the data should be transformed before plotting. Or before visualization. I think that would be before visualization. So that's it. So these are what we mean by the grammar. And lastly, there is also theme. So the theme is how do we want the chart to look like, to look and feel, if we should put it that way. Or let's say look like. So for example, I may want the background to be yellow or blue and so forth. So all those things are themes that we can look out for. Now to do this, we need the ggplot tool. Okay, so I think everybody has installed it, right? Yeah, so we need library. If you have not installed it, then you have to go ahead and install ggplot tool. Okay. So ggplot tool is what we use in doing this. Okay. Now, so there is a book on it. I have also sent it to you as reference. Okay, so please check to make sure that you of course we need the DPLYR as well. So always write this so that when you are revising at home, you don't, you know that you need this package for the next thing you are doing to go. Okay. Now, so let's look at our listings data. Let me see. There's also review. Review, scores, there's ratings. Let's see what this is. So this is an integer. Okay. So if that is the case, I can, for example, okay, so let's get a scatter. What? Hey, we don't have time. So listings. Okay, so it means that I take listings, then what we need to use is ggplot. Okay. Now, So we take aesthetics. So that's the AES. What are the AES? The data, what should be X, what should be Y, and so forth. So that's the mapping. Okay. So I can let my X be the ratings. So review, ratings. So it means I need to go up. Oh, what was the review score? Why is it not coming up? Okay, so you need to go review score. Why can't I find it again? It was review. Okay, so let me just go and copy once I can get it here. So review score ratings. I want to check the price, whether the price has relationship with. If you use price L, the previous one, then you must use price. Is that okay? All right. So now, what this means is that, so you see the way this is, it gives me, so now we don't need that PAMA and so forth, because ggplot2 will just what? Give you, it will occupy the entire space in it. Okay. So this is, and this, I can actually create it and say it is, let's say, B. So I can actually assign it, and that's the beauty of ggplot2. So I can assign this as B. So B is an object. If I let's just take this one off completely. Then I run B. So you can actually, in ggplot2, we can assign a name to the plot. We can't do so in the Bezier. Is that okay? So now what is happening is that I have listings and I have used pipe to have access to the columns. I have assigned X as a review ratings. I have assigned price as what? The price of what? The A and B hostels. So that's the aesthetics. Is everybody okay with this? Remember the grammar we talked about. We have what? Data. So our data is the listings. Our aesthetics, we've mapped it, which is what we are left with is the geometry. What we want to show. In this case, we want to show points so that we can see what? The relationship. When we get the points, we can superimpose what? A line. And so you can build upon it. That's the beauty of this ggplot2. So now the beauty is that once I have B, I can add on to B's with the plus sign. So I can then call geom point. So I want geom points like this. What do I want to do now? What I'm saying is that add the points, which will be X, Y. So there it is. Is everybody okay with this? Okay. So it has a geom point. And you can see that the scores with higher ratings are expensive. Is that okay? Not all of them, because some of them are also down there. But generally, as the scores increases, there is a gradual increase in the price. Of course, if it is expensive, they will tend to what? Add more of these things. Okay, so you see, it gives us what? A warning that some of them are what? Missing. And so Okay, so if you look at what is happening, you can go to the cheat sheet that I sent you, and you can do this on your own. Where would that one be? Okay, so okay, so if you look at it, it starts. So here too, it shows you what. So the basis we talked about, you have data, you have the geom, okay, you have the coordinate system. So when you put all this together, you get your graph, right? And it tells you the geom are statistics like size, color, X and Y locations. So we can put colors in there and so forth. Okay. Then this is a complete template. So you have your ggplot2 data is equal to the data you are dealing with. Remember, our data is what? The listings. We could have also put the listings within the ggplot2 if we don't want to use a pipe. So ggplot2 data is equal to listings, and then we can have our statistics and so forth. But if you like, another way is to also use a pipe. So it depends on you. Whichever one is better for you, you use it. Now look at it. So for you to get a plot, you need the data and the geom. Other than that, there will be no plot. Is that okay? And that's what we did. The rest are optional. Start, coordinate, positions, and so forth. Those are all optional. So there are also examples here. So you see, in this case, they put the data within it. Another way is to just do MPG, then pipe, and then we put in what? ggplot. So the grammar of graphics and the grammar of data wranglings are intertwined. And we'll use the same concept to move to the big data part, which is the Spark LYR. So please make sure that you go through this. So with what we have done, you can now go on. You see the scale plot, which is just an abridged version of what? The ggplot2. So please use the cheat sheet to go through this. It tells you about, when you go to the next one, geoms. So graphical. So you see, we do this. This will just give us all the plot in its basic form. X and Y, done. B is also a plot. Then if we come here, the next one we are adding on to it. So blank, no, nothing will be plotted. B, curve. Then it means we want to fit a curve to it. That will be done. Geom path. If you want it to be like that, you can get it. If you want a polygon, it will draw a polygon around it. Rectangular, ribbon, then lines. So please take note of all this. They are just, now you just have to be running them to see what actually you are getting. AB line, it will get a line with an intercept. H line, horizontal line. Remember we did AB line, HV and H, same thing over here, and so forth. When you have one variable, you can get a plot, you can get the density, you can get dot plots as we did in the Bezier, frequency polygon, you can get a histogram with geom histogram, geom QQ plot will give you a QQ plot, and so forth. If you have a discrete variable, in this case, discrete means what? Qualitative. So you can have geom bar, okay? Geom box is there, that will give you a box plot and so forth. So Two variables, continuous. Geom label, jitter, point, we just use point. Geom quantile, geom rag, geom smooth. Text, we can add text to various sizes. Discrete and continuous, we can get column, which is just like that. We can also get box plot, geom box plot, dot plot, the violin plot as well, okay, with geom violin and so forth. So all this, it gives you different sort of what graphs to use. We can get contour lines, okay, with also geom contour and so forth. And maps. So those who want to go, if you are dealing with spatial statistics and so forth, by various distributions. Some of the probability distributions you have, we can also illustrate them. Density in 3D, continuous functions, visualization of errors, okay, crossbar, geom error bars, line range, point range, maps. So ggplot is good. So for example, if you are doing remote sensing, this geography stuff, you can still use R and then geom to do, the ggplot to do so. And so from then you can go to the start. It also goes through, it tells you what start is and so forth, several of them. So please go through some of this whilst home, and then when you come back next week, we can start with our big data, which is Spark LYR. Enjoy the rest of the day. Thank you.
So the exams will be on 13.
Yes. All right. Enjoy the rest of the day.